Hello students, let's start this session. In this session we are going to learn about levels of parallelism. Let's start. Loop level parallelism, subprogram level parallelism, job level parallelism are some levels of parallelism. In this session we will discuss on loop level parallelism. What is loop level parallelism? It extracts those tasks from the loop that can be run parallelly on different processors at the same time. We understand it with an example. Here we are taking an array named L. It has 5 values. When compiler will read this statement, compiler will allocate 5 memory spaces for this array, and at these memory spaces 5 values of the array will be stored, and every value of the array will be given a numbering, and this numbering is called an index. 20 value has 0 index, 2 value has 1 index, and in the same way other values have indexes. So now here for loop will use one statement which will add 70 value to every value of the array. In 5 times it will add 70 values. Every time this loop will add 70 value to each value of the array. Let's understand in detail. Suppose this statement takes 2 minutes for its execution. When loop will come to 0th index, then this statement will add the 70 value to 20, and when index will come at 1, it will add 70 value to second value. Here this statement does not need the result of past step statement. This statement is independent of the past step. Every step in this is independent. When index comes at 2, here it also needs not to use the result of last step, because it needs only the current index value for its calculation. And in the same way, when index comes at 3, it will add 70 to 9, and when index comes at 4, it will add 70 to 6. So for doing these 5 steps, it will take total 10 minutes. Total 10 minutes will be taken for completing this task. So now if in our computer system we have more than one processors, then we can keep each step into separate processor, because these are independent steps. Rather than doing it one by one sequentially using separate 2 minutes, we can get these steps executed parallelly through different processors. And when these parallel tasks will be executed by different processors, then it will take only 2 minutes. Only within 2 minutes, every task will be performed, and within 2 minutes, complete array will be processed. So you have seen how it recognizes the type of parallel tasks. So what is loop level parallelism? In loop level parallelism, we can personalize so many things. And if the compiler can figure out, we can parallelize so many things only when compiler can figure out if loop is a parallel or not. If loop is a parallel, then compiler can produce parallel codes that can be run parallelly on different processors. Example for a multi-core processor also. So it extracts parallel tasks from loop, and it often comes in programs where data is stored in random access data structure. So array is a random data structure where we can get value from any particular location of the array. So in such a data structure, program or loop can iterate over the data structure, because it uses indices. It uses index to get any particular value from random access data structure. So we stop this session here. I hope you would have understood it very well. So thank you. Have a nice time. Keep on watching our channel and please subscribe our channel. Thank you. Bye bye.